Good morning. My name is Shekhar Garde. I'm the Dean of Engineering here at Rensselaer Polytechnic Institute, and I want to welcome all of you to this very special event where we will formally launch the Center for Mobility with Vertical Lift, or MOVE. And it is really my special honor, my privilege to introduce to you a very special person, the 18th President of Rensselaer Polytechnic Institute, the Honorable Dr. Shirley Ann Jackson. Now, before I invite her to the podium, I want to give you a very brief introduction. As many of you may know, Dr. Jackson is a theoretical physicist. She holds an SB in physics and a PhD in theoretical elementary particle physics, both from MIT. As a theoretical physicist, her research has focused on condensed matter physics, especially layered systems, and the physics of optoelectronic materials. She's the first African-American woman to receive a doctorate from MIT in any field and has been a trailblazer throughout her career, which has spanned academia, industry, and government. Dr. Jackson was appointed by President Bill Clinton as the chairman of the U.S. Nuclear Regulatory Commission, the NRC, where she served from 1995 to 1999. From 2009 to 2014, Dr. Jackson served on President Barack Obama's Council of Advisors on Science and Technology, or PCAST, helping the White House in formulating policy in many areas of science, engineering, technology, and innovation. Her work as part of PCAST and PTAC and the Advanced Manufacturing Partnership Steering Committee 2.0 really led the formulation of U.S. strategy on advanced manufacturing and focused it on re-energizing the manufacturing sector of the U.S. Economy. As you can imagine, Dr. Jackson has a very long list of impressive awards and recognitions to her name, and I won't go through all of them, but I'll just mention a few here. For example, in addition to the doctorate from MIT, Dr. Jackson has been awarded 53 honorary doctorate degrees. She is a member of the U.S. National Academy of Engineering. And in 2008, Dr. Jackson received the American Society of Mechanical Engineers Ralph Coates Rowe Medal. I'm particularly proud of this honor. In 2016, President Barack Obama awarded Dr. Jackson the National Medal of Science, our nation's highest honor for contributions to science and engineering. And perhaps what has touched our life here at Rensselaer most directly is the fact that since 1999, Dr. Jackson has led an extraordinary transformation of our institution, of Rensselaer Polytechnic Institute. I can tell you as the Dean of Engineering that she is the strongest supporter, strongest champion, and strongest cheerleader for initiatives that bring many disciplines together, that push the frontiers of knowledge, and that make the world a better place. Which brings us to the Center for Mobility with Vertical Lift, MOVE. Right? So without further ado, it's my pleasure to invite Dr. Jackson to the podium.
Well, thank you, Dean Garde, Shekhar, as I like to call him, and good morning to everyone. You know, I'm delighted to welcome all of our guests to this formal opening of the Center for Mobility with Vertical Lift, or MOVE, in the Rensselaer School of Engineering. And I'm a theoretical physicist who interlopes into engineering, and so it is a special pleasure. And you know how important our School of Engineering is, the things that we have done here, and the importance to Rensselaer Polytechnic Institute as a whole. And at Rensselaer, we believe in taking on the very hardest of problems, the grand challenges. We also believe that to make headway against them, we must work alongside talented partners in government and industry. In fact, I'm a fundamental believer in what some refer to as the three-legged stool of the linkage among government, industry, and academia. And to this end, I would like to acknowledge, and if you could just wave your hand, Dr. Bill Lewis, who is director of the United States Army Aviation Development Directorate and head of the National Rotorcraft Technology Center, which provided seed funding for MOVE. Thank you for being here. I also thank Mr. Elias Regas and Dr. Rajneesh Singh of the Army Research Laboratory are they here? Thank you for their support and collaboration. We're grateful to Dr. Vineet Sahasrabudhe and Mr. Steve Weiner of the Rensselaer class of 1978 for the support of the Sikorsky Aircraft Corporation. We thank Mr. Chris Jaron, also of the class of 1978, the CEO of Terrafugia, for the generous funding of research projects at MOVE. We welcome Mr. David Coopersmith, again, of the remarkable Rensselaer class of 1978. As I have to say, you know, it's the great class of 1968 and the remarkable class of 1978. And Mr. David Coopersmith is the Vice President and General Manager of Boeing Vertical Lift, a very important industry collaborator whose Chief Technology Officer we'll be welcoming soon here to our campus. And we're delighted to have with us Mr. Mike Hirschberg, who is Executive Director of the Vertical Lift Society. Thank you for joining us. And it is a great pleasure to see so many of our own alumni and alumnae here, because the long-standing excellence of the education offered by our Department of Mechanical Aerospace and Nuclear Engineering is readily apparent when one considers the degree to which Rensselaer graduates dominate the field of vertical flight. In the last 25 years, 3 of our alumni have won the Dr. Alexander Clement Award for notable achievement in advancing the field of vertical flight aeronautics. It is the highest honor bestowed by the Vertical Lift Society. And they include Dr. Kenneth Rosen of the Rensselaer classes of 1965 and 1970, who's with us today. Thank you. Dr. Rosen's expertise in a wide range of aerothermodynamic topics has been incorporated in the systems for many helicopters, including the UH-60 Blackhawk. Now, Mr. Steve Weiner, whom I mentioned earlier, is another Clement honoree and chief engineer of the JMR Defiant and the X-2 technology demonstrators. And although he is not with us today, I'm sure that many of you are familiar with the work of our third Clement honoree, Mr. Frank Harris of the Rensselaer class of 1956, who was chief engineer of the Bell OH-58D Scout helicopter, one of the most successful Army aviation procurement programs. Now, as you know as well, I hope you do, Rensselaer graduates have been connecting people and communities since our founding. They have designed and developed canals, bridges, the transcontinental railroad, ships, aircraft, vehicles for space exploration, as well as many foundational technologies in the digital realm, offering a previously unprecedented mobility to people, to goods, and to ideas, powering our economy and undergirding our military strength. And when I consider the characteristics that have allowed Rensselaer people to continuously reshape our world, I often think of the great aircraft designer Robert Widmer of the Rensselaer class of 1938, who let nothing stand in the way of the future, and especially not his bosses, because the day after test pilot Chuck Yeager broke the sound barrier in 1947, Mr. Widmer told his manager that he wanted to design the first supersonic bomber. And when his manager asked him to stick to the existing contracts, he designed the aircraft on his own time. So 2 years later, when the Air Force wanted such an aircraft, his design for the B-58 just happened to be ready. But this was hardly the only time Mr. Widmer defied the higher-ups. He also secretly designed the F-16, a lightweight fighter, without their consent, and hid the prototypes. And again, when the Department of Defense wanted such a fighter, the design just happened to be ready. So surely now, and I don't want to give the wrong impression, we do not urge our students to defy their bosses. But with MOVE, we are embracing the spirit to not only anticipate the future, but to race forward to meet it and to shape it. And together, all of us can envision the opportunities. The future of vertical lift programs is one of 6 key modernization priorities of the United States Army. In the private sector, with the emergent field of multi-rotor electric vertical takeoff and landing aircraft, we are moving far beyond hobbyist drones into the realm of air shipping and air taxis. Uber and Cora, founded by Larry Page of Google, are both developing air taxi networks and air taxis as we speak. And Terrafugia, under the leadership of our alumnus, Mr. Jaron, is developing personal air vehicles, cars that can both drive and fly. And I have to tell you that I've stayed on the ground, but as someone who used to build and race aerodynamic go-karts as a child, I'm looking to get into the driver's seat of one of these. Now, as you know, VTOL aircraft are going to help us address many challenges, including national security and emergency response. And both of these are critically important. And you can see that given the increasing frequency of natural disasters such as recent Hurricane Florence, earthquakes, and tsunamis, and challenges that our military face around the world. eVTOL aircraft in particular represent a new form of sustainable aviation that can help us to replace greenhouse gas emitting vehicles with a cleaner form of transport, as well as ease the condition of the congestion on our roads and improve people's lives by cutting long commute times down to size. But to make potential revolutions in vertical lift a reality, and to create larger, faster aircraft, both piloted and autonomous, with greater endurance and the ability to navigate unpredictable conditions, both on battlefields as well as urban and suburban environments, many fundamental research questions await us. We require advances, obviously, in aeromechanics and aerodynamics, in nanotechnology and advanced materials, in energy storage and management, in autonomy and control systems, and in real-time diagnostics and decision-making. And at Rensselaer, we have a special opportunity to contribute to vertical flight, the emerging technologies in artificial intelligence and machine learning and data analytics, in edge computing and immersive systems, areas in which Rensselaer is making significant advancements and investments along with our research partner, IBM. Now, under the leadership of Professor Farhan Gandhi, our Rosalind and John J. Redfern Jr. class of 38 endowed chair in aerospace engineering, MOVE is convening faculty and students in many, many different disciplines and leaders in both the private sector and government to focus on advancing vertical lift technologies. And this makes MOVE a powerful example of the paradigm that we term the new Polytechnic. The Polytechnic in our name comes from the Greek for skilled in many arts. And as the new Polytechnic, we still educate our students in the fundamentals as we serve as a great crossroads for talented people from across all disciplines, sectors, geographies, and generations, collaborating to address the most complex global challenges and to develop and use the most advanced tools and technologies as they do so. And so we're very proud today, with the creation of MOVE, to formalize an important aspect of the new Polytechnic that focused on the technologies of vertical flight, to which many of you already have contributed so much. And so let me end my remarks this morning by quoting Igor Sikorsky, the great pioneer of vertical lift. And he said, according to the laws of, and you'll understand if you know anything about me, it'll be a quiz at the end. And he said, according to the laws of thermodynamics, the bumblebee cannot fly. But the bumblebee does not know the laws of thermodynamics, so it goes ahead and flies. I used to collect live bumblebees. So, as you know, at Rensselaer, we do know the laws of aerodynamics and aerothermodynamics. And with the advent of this center, the Rensselaer Center for Mobility with Vertical Lift, we are bringing together many bumblebees among our faculty, our students, and our partners who will invent new ways to fly. And in doing so, will change the world. Thank you all. Thank you for being here.
Thank you, Dr. Jackson, for that fantastic speech. Before I introduce our next speaker, I want to recognize a special individual who has joined us today, Caitlin Rooney. And maybe you can say hello. Caitlin is the Capital Region Director for U.S. Senator Kirsten Gillibrand, who you know that Senator Gillibrand is a strong supporter of science and technology in certainly this region, and she serves on the Senate Armed Services Committee. Now it's my pleasure to welcome to the podium Professor Farhan Gandhi, the Rosalind and John J. Redfern Jr. Chair in Engineering and the Director of MOVE. Farhan.
Well, good morning. Thank you, Dr. Jackson, for a very inspiring opening address. And it's really good to see all of you this morning again. The thing about MOVE is we are at a very unique time in our entire history. And when you are working with a mature field, your topics are defined. And you get to add your voice to those questions. But when you're in new fields, like you have at eVTOL, the questions themselves are unknown. So we are spending a lot of time figuring out what are the important questions and what do we work on. And that is really exciting. And what is very exciting is when somebody like Mark Moore, who was here as our Lowy lecturer last evening, comes to you and says, how do you find these topics? Because these are just the right topics to work on. And that tells us that our intuition is correct. So you took a tour of MOVE and you had the opportunity to speak to all our graduate students last evening. I'm just going to put up about 3 or 4 examples of the kind of work that we do and the kind of questions that we ask here. So here's an example. You have a hexacopter with 6 rotors, and let's say one of these rotors fails. What do you do? Because with electric VTOL, this is going to be a question, this is going to be a problem. They have all these electric motors, you have all these power cables, and something can go wrong. It turns out that if you actually design your control system right, you can tolerate for this kind of a failure. So if you look at this particular graph over here, on the x-axis you have time, on the y-axis you have the RPM, or the speed of these individual rotors. These rear rotors that you have here, 3, 4, and 5, spin a little faster because they need to generate more thrust for the aircraft to pitch nose down and propel forward, whereas these front 3 rotors spin a little slower. They're here. And then at t equals to 5 seconds, this rotor number 1 fails. So you can see its RPM has gone to 0. And then there's a little bit of a transient response, and all the other rotors start to adjust. So here's a rotor that kind of, this is rotor number 4, and these are the other rotors, and they all adjust. And if you look at how the aircraft flies, this is when the failure occurs. There's a little bit of a transient, and then it recovers its attitude, and it recovers its flight path. So this is what happens. You had a little bit of a failure, 1 rotor failed, and then the aircraft recovered. It did not fall out of the sky. Big helicopters auto-rotate, but these small multi-rotors, because of the degree of redundancy that they have, and if the control system is designed right, there are other methods of recovery from failure. Here's a second example that we work on. Big helicopters, single rotor, the kind of interactions you have are basically main rotor and tail rotor, main rotor and probably the stabilator. When you have a quadcopter, a hexacopter, an octocopter, many rotors working in close proximity, it is a mess. And if you look at this case here, this is a quadcopter flying in what we call the cross configuration. So you have 2 rotors in the front, 2 rotors at the back, and the aircraft is flying upwards. This is a top view, so the wind is coming from here. The front rotors do okay. It turns out that the rear rotors start to lose a lot of lift. So you see these areas of dark blue? That's no good. That's about 20% loss of lift for the same power that you're putting into the rotor. Now, you know, NASA has seen this too, but we've taken the next step. We've asked, why does this happen? And if you take a single rotor over here, and this is where the location of the second rotor would be, but it's not there. And if you simply cut planes over here and you look at the wake of this front rotor, what you see is a region of very strong downwash over here. And that downwash starts to become weaker as you go further back. So this region of downwash over here, which is very strong at the front of the rotor, is causing the loss in lift. So this is very important to understand. And furthermore, if you reorient this aircraft, so it's not flying in a cross configuration, but what we call the plus configuration, one rotor in the front, one at the back, and two on the sides. Now it's flying forward. This rotor is in the downwash of this of this front rotor, but it's far away. And these two rotors on the sides are in the upwash of this front rotor. So now, instead of a 20% loss, what you get is a 6 to 8% improvement in lift over what would have happened if this rotor was not in proximity. So how you situate your rotors matters. And in multi-rotor aircraft like eVTOL, this is a very important question that the community faces today. Here is a third example. And one of the most beautiful things about these electric VTOL aircraft is their simplicity. It's simply, there is no pitch control, no collective pitch control, no cyclic pitch control. All you have is variable speed. You put more power to the motor and it spins up faster and it generates more thrust. And that's your control mechanism. It is so simple that this is why people have been building it out in their garage. The issue is it works very well for a 1 pound aircraft or a 5 pound aircraft. But when you think about air taxis with 6 foot, 8 foot, 9 foot, 10 foot rotors, now variable RPM control has a problem. Because you can put more power into the motor, but there is something called the inertia of the rotor. So you put more power, but the rotor does not spin up that fast. And if the rotor does not spin up that fast, the thrust is not generated that quickly, which means that there is delays. The aircraft becomes more sluggish, it's not as maneuverable. So you're no longer driving a Ferrari, you're driving basically an 18-wheeler. So here is an example. This is time on the x-axis. This is the heave rate. So you're trying to get into climb, right? You're trying to get to commanded rate. And if the rotor is small, this is in blue, you have the 1 foot diameter rotor, it gets to where it needs to be very quickly. But as the rotors become larger and larger, that process becomes slower, and the handling qualities of the aircraft go down. So at MOVE, we are posing these questions, and we are finding the solutions. So a lot of this was on eVTOL, but we also work on the big aircraft, the Defiant type aircraft that the Army is interested in as part of the JMR program. So if you look at these aircraft that want to fly at 230, 240 knots, large parts of the disc are basically in what is called reverse flow. So in reverse flow, the wind basically goes from the trailing edge of the airfoil to the rounded leading edge. Normally, in normal flow, the air would go from the rounded leading edge to the trailing edge. This reverse flow condition is a no-good condition. You get negative lift, you get a lot of drag, you get a lot of pitching moments, you get a lot of vibration. So what do you do? What we at MOVE have seen through CFD and through experiment is that if you reflex camber this airfoil here, what you can get is the separation bubble on the lower surface becomes much weaker, the ram pressure that you have on the upper surface becomes much weaker, and this drag, here you have the drag coefficient versus the angle of attack, and this blue line is the baseline airfoil, and this is a reflex camber design. Your drag can drop by about 40 to 50%. So these are the kinds of problems that we are trying to address and MOVE. But as President Jackson said, we can't do much by ourselves. So we are very grateful to our faculty team. We have a team of 10 faculty at MOVE that represent a very wide range of disciplines. And we have partners at different academic institutions, such as the University of Southern California, University of Portland. We have Professor Christina Ivler, and the University of Maryland, the Alfred Gesser Rotorcraft Center, which is represented here by Professor Chopra, who is himself a Clement Award winner. And we are very grateful to our sponsors. We have the government sponsors, federal, and the state of Israel too, and the state of New York. A lot of Army sponsors and a lot of companies. We thank you for your partnership and for your funding. And to RPI. Starting from our department chair in mechanical and which is Dr. Suvarnanude, and our Dean of Engineering, all the way up to Dr. Jackson and her entire cabinet. We've had a lot of support from everyone on the way, and I really thank you all for all the support that you've provided. So Dr. Jackson mentioned our legacy. RPI's legacy in vertical lift is mind-blowing, and these are the 3 winners of Clemen in the last 25 years that Dr. Jackson spoke about, our crown jewels, but that is hardly all. There is much, much more. So on the next slide, I have some leaders and legends in the field. Bob Lowy, on whom I presented a lot of material yesterday, right before the Lowy lecture. And then we have Bob Ormiston. Dr. Bob Ormiston is basically, I consider him to be the high priest of rotorcraft dynamics of the US Army. And Mr. Bob Blackwell, who is here, was the last word on dynamics at Sikorsky. So this is what you have. And Fred Schmitz was also spent a most significant part of his career at the US Army, and he is the expert in rotorcraft acoustics. And then there is Professor Pat Curtis, legendary professor at Princeton for 33 years. So our legacy in vertical lift is incredible, and I'm always so proud of it. But that's not it. There's more. So here we have Chris Jaron, one of the few people you can buy a flying car from. So, you cannot order one on eBay. You cannot.
Sign you up today.
Yeah. And then we have Mr. David Coopersmith. So David Coopersmith is the VP and the general manager of Boeing Vertical Lift. So he has under him about 8,000 employees at Philadelphia and Mesa. He was also in 2018 the president of the Vertical Flight Society. And he will come up and speak to you next. Coop, goes by Coop to friends. I will just say I'd like to mention one final point, that at MOVE, we know that we stand on the shoulders of giants in vertical lift, and we aim to advance your legacy. So thank you very much for your attention, and I'd like to invite David Coopersmith.
I don't have any cool charts. As a proud member of class of 78, and a third of us are here, I was just trying to get through thermodynamics too. But it is an honor to be here, Dr. Jackson. Thank you. Congratulations on this extraordinary capability that you've now created. Professor Gandhi, congratulations. I would tell you, walking around yesterday, having breakfast with the students, seeing the ecosystem that you are creating is just going to continue to accelerate learning and do great things for all of us in the industry, particularly with a focus on vertical lift and vertical capability. And you're right, this is such an amazing time in our life cycle in this industry with all new demand signals coming to us. It is absolutely extraordinary. As an alum, it makes me uniquely proud to come back and talk to the students and see the extraordinary quality of the faculty and the investments made in the Institute. It's just really cool. And coming back 40 years later, it's just an extraordinary experience. I love the phrase outside, why not change the world? In my job, I make coffee and sweep up at night, and I move some papers. They don't let me do real engineering anymore. But I have the privilege of knowing 2 people who've had the courage and tenacity to really go out and change the world. And one of them is here, my roommate, Steve Weiner. What he has done in his career as a leader in a new kind of technology that we have the pleasure of partnering on, and you saw it earlier, Defiant, this compound coax lift offset capability will change the way we fight and change the way we fly and change the way we move people in the long term. And knowing that this institution prepared him, and as his roommate, I got to see how it really prepared him for this, is just amazing. And then another alum, Mark Jenks, who works for the Boeing company and leads our activity on the next generation aircraft, is another individual that you have trained to change the world. And I just think that's absolutely extraordinary and amazing. As I said, I had the privilege and pleasure of talking to some of the students this morning, and the quality of thought, the quality and diversity of thought, the quality, diversity, and insights they provide as both an alum, as an American, and as a citizen make me extraordinarily proud. So I really just wanted to say congratulations to this institution. Congratulations on this fantastic investment in MOVE. I know as someone who uses that capability now and has the privilege of working with individuals in the industry that try to ensure that we protect heroes and save lives, what you're doing here is changing the world. So thank you so much and congratulations.
Thank you, David. It's my pleasure to invite Dr. Vineet Sahasrabudhe to the podium. Vineet is the Director of Engineering Sciences at Sikorsky Aircraft Corporation and a technical fellow of the Vertical Flight Society, elected in 2018. Vineet.
Thanks for introducing me. I am the Director of Engineering Sciences at Sikorsky, and as on behalf of Sikorsky and Lockheed Martin, it is my pleasure to congratulate you all on the opening of the MOVE Center. I think Dr. Gandhi has assembled a fantastic team of faculty and students for the MOVE Center, and I got to meet some of you yesterday, talk to you about your research, and I came away really impressed. I believe opening the MOVE Center is the right move at the right time. And as many of you students graduate over the coming years, I'd like to invite you to come work for Sikorsky, to come work at Sikorsky as employees or even as interns. Our Connecticut location is only a couple of hours south of here, so I really look forward to that partnership. The connection between Sikorsky and RPI goes back a long way, and there are literally many dozens of RPI alumni at Sikorsky. I'd like to mention three of them, the most prominent ones who happen to be here today, and others have already done so. But the first is Bob Blackwell. He retired from Sikorsky a few years ago as the technical fellow in Dynamics. And I happened to work for Bob in my first job at Sikorsky, supporting the Comanche program. The second is Steve Wiener. You heard mention of him today, and you probably heard his lecture yesterday. I've worked for Steve Wiener for several years. He's now the chief engineer of the Defiant program, and in various capacities over many years, he has been a mentor and a guide to me. I've also had the pleasure of working for Dr. Ken Rosen. He was the VP of engineering he retired right about the time I started at Sikorsky. So in a way, indirectly, I worked for him. And I also drove him up from Hartford yesterday, so I'm still working for Ken. So I'm not an RPI alumni, but as you've probably figured out, the path to success at Sikorsky is to work for an RPI alumni. So I hope some of you will at least consider coming to Sikorsky and joining us in the cool stuff we do. And finally, I want to thank Farhan for including us in the activities and the events over the last 2 days. They were very interesting. And once again, congratulations on the MOVE Center.
And now it's my pleasure to introduce to you the final speaker of the day before we cut the ribbon, Dr. Bill Lewis. Dr. Lewis is the director of the U.S. Army's Aviation Development Directorate and he's also the head of the National Rotorcraft Technology Center. Dr. Lewis has had a great year. In 2018, this year, he was elected Honorary Fellow of the Vertical Flight Society. And also this year, he won the Quad A Joseph Cribbins Army Civilian of the Year Award. Congratulations. Yeah.
Good morning and hooah. I'm the guest. I'm the surprise guest lecturer. They couldn't get Lady Gaga, so you got me instead. I was here a couple years ago to give the Lowy lecture, and Farhan walked me around the campus, showed me what was going on, and a lot of good work going on there, right? In my business, it's all about kind of collaboration, and I appreciate the industry, academia, government initiatives that we have, because that's the way we do work in the helicopter industry. That's exactly what we do. We try to pair all those up, and as a part of that, I sponsor 3 centers of excellence. Every 5 years, we do a competition to get some centers that for academics that will help us interface with us, those kind of things. And RPI was one of the original centers. I guess it was about 20 years ago when we first started that program, before me. So, was it a little more than that? The voice of experience, 1981. So there you go. So as we kind of work through this whole process, the thing that we try to do is encourage collaboration. We try to get people to talk to each other. The folks that work for me, I tell them, if you go to a meeting, never go to a meeting that you don't want to know an answer out of that meeting. Never go to a conference that you haven't shook hands with just about everybody that you don't know there, because if you're in the helicopter industry, you're going to meet them again. We're a small crowd. We do a lot of the same kinds of things. We go to the same kinds of events. So that collaborative spirit has to live within you to be able to do those kind of things, all right? As a mentor, I sit down and I talk to the younger folks and then some middle grade engineers that are working for me. And one of the things I tell them is, nobody knows what you're thinking. If you want something, you need to tell the people that you're working for that that is something that you want. That is a job you want to try. So you sit back and you think, well, yeah, okay, logical. But a lot of people don't do that. Dr. Gandhi came to me after the Lowy lecture and told me then, I want this to come back to be one of the best rotorcraft centers of excellence in the world. He told me that. He goes, how can I do that? How can you help me do that? Now there's a good thing about mentoring, right? Because the protege gets some advice, but believe it or not, the folks that are giving the mentoring advice kind of buy in, okay? And at that point, we started talking about what we could do and how we could do it. We were just getting ready to go through the Center of Excellence down select, and he was trying hard to get something rolling, kind of late for that cycle. But because of his request for help, we were able to squeeze around some of that funding and manage to get a couple tasks funded and get some money out there to help. And now 2 years later, after being here in 16 and coming here today, you get a whole different feeling about the momentum that is gathering in creating this Center for Rotorcraft Technology. There's a saying in the race business is you run your fast horses if you want to win. And Farhan, I believe, is a motivated, fast horse in this rotorcraft leadership set that we have. So Farhan, I got to give it to you, man. You have done an outstanding job of starting this from the very beginning, initiating it, working hard to execute, and now to keep that momentum going forward to be a great center and one of the centers of excellence that we're looking at for Army aviation. So my hat's off to you. So thank you very much. Break. Just a little business here. For those in the crowd who may be interested in a little item called FARA, The award will be announced, or not the award, the solicitation will be announced at 1700. That's 5 o'clock, Coop. So yeah, so all of those things are happening, and it's an exciting time to be in the rotorcraft business. I mean, with all the eVTOL, with all the things that we're doing in the Army, Navy, etc., it's a great time to be here. Every one of you students should be excited about being here. I know you just think it's a normal part of coming to school and doing all that kind of stuff. Trust me, for the last 30 years, people that were sitting in your seats were not presented as lucrative opportunities as you are being presented now. So enjoy it. Enjoy it. Farhan, thank you much.
Thank you, Dr. Lewis. And now I'm going to invite President Jackson to formally inaugurate the, the center by cutting the ribbon. And we're going to try to do it. 3 of us are going to try to do it.